speaker and oh
Yeah, that's at your side. You have to do that.
yeah,
Yeah.
I can pin
So
your
if you go up to view, you can choose gallery or you can pin
just pinned Phil,
pin fill.
your pinned Phil.
Okay. So I've got just another camera I can cut to show you what I'm doing. I've got the same model that you guys have in your demo racks here, an RPI 214. Uh,
Mhm.
so the product name indicates the functionality. So um, the RPI indicates that it has individual current outlets monitored. If it's an RPU, then it's that the outlets are unmonitored, U for unmonitored, and you just get current monitoring on the inlets. Um, the 2 in 214 means you've got two inlets, and the 14 is 14 outlets. Um, uh, so a 114 is just a single inlet and 14 outlets, except for when it's a 32 amp inlet, then it's a 314. So it's there's no sense to the or little
Is
sense
it
to the
explained at the
products.
website in case this
Yes,
is
so did I not send you guys the dealer price list? I'll do that as soon as we're finished.
yeah.
Um, yeah, but that's all explained. Yeah, there's also a page on the website with variation details.
Yeah.
Um, so
But will you recommend us to have more than one model available?
see, a lot of this has grown from the BBC because the BBC they own more of these than anybody else, and so the BBC drove early development very strongly. And so the BBC didn't want individual current monitored outlets on all their units, and a lot of this is down to the fact that they have a third party who do all their IT, and so they have to pay for every IP address they use internally, and they have to pay for monitoring services, and so they wanted to minimize those expenses whilst still having some controllability. So you'll see some aspects of the product that there are some options. You think, what? Who would want that? But invariably, that's the BBC would want that, and they've stayed in the product generally. So, I mean, you obviously you saw it at the show. Let me turn to this little USB camera. I've got one here. Um,
Mhm.
exactly the same setup as the show, except
Yeah.
I've got both of the inlets powered, and I've also got some of the other features that we didn't have at the show. So the multi-sensor monitoring for humidity and temperature and things like that. I'll show you how that works.
Yeah.
So I mean, to recap what we saw at the show, it's a 14 outlet power distribution unit with dual inlets. You can see the dual inlets are indicated here. It's currently running on inlet A. I mean, this camera's not great, but inlet A is a green LED, and inlet B is a red LED. If I unplug inlet A, you'll see we've flipped over to inlet B,
Yeah.
and we've it's honking the alarm for 30 seconds. Um, the alarm can be either all the LEDs flashing, or the beeper, or a combination of those, and also a GPI on the back of the machine. So if you want a big red light in the hallway, uh, let's put that power supply back in again and cancel the alarm. Um,
Okay, so
And it, and it,
just to be clear, if it's red, it means it's plugged, but it's not the one being used, right?
yes, so if it's red, there's an input available on that one. If it's green, then there's input available and it's running on that inlet. Um, and in the configuration software, we can set what the preferred behavior is, whether it's A and we fall over to B as necessary, or B and we fall over to A, those kind of things. But that's all in the Windows configuration utility, which we'll get to a bit later. The outlets, all as supplied, it comes with a 3.15 amp anti-surge fuses, which is very standard for broadcast PDUs. Now, of course, it's got dual 20 amp inlets and 14 10 amp outlets. And again, that's kind of standard for a changeover PDU. But of course, the first thing people say is, "Oh, what happens if I want to take 10 amps out of 3 outlets?" Well, buy the 32 amp model or don't, you know. But there's no modern equipment that uses that much current anymore. That's very unusual nowadays. You know, generally speaking, 3.15 amp anti-surge fuses are entirely adequate. And normally, when I install these, I normally tape a spare bag of fuses to the lacing bar on the back of the unit, so that, you know, if somebody does blow a fuse, they don't have to phone me up. I can just tell them there's a bag on the back. So that's very sort of standard, nothing that you won't have seen before. But then, of course, there's this little OLED screen, which you know, is a status display. Let me see if I can get this a bit better. And it's got 4 buttons around the edges, and as well as being able to monitor the outlets. So I think I've got something plugged up on outlet number 8. I have, yeah. And the labels that we set inside the inside the Windows configuration utility are the same labels as you see in the web interface, but they also appear on the little display here, and we can see you know, what equipment's pulling how much load. Same with the inlets. We can see the state of the inlet and how much is being pulled on that inlet. And
that's the total.
Yes, exactly. Inlets are in total, and outlets are individual. And then we can also look at the sensors. And this unit, I haven't plugged up any sensors yet, but we'll get to that a bit later. Rescan sensors. Well, there's nothing there, so no, that's pointless. The really nice thing is this button here, which is just marked unit, and that allows us to, for example, see the IP address if we don't know what the IP address is. So out of the box, the default behavior is it will go and look for a DHCP server for 30 seconds. If it doesn't find one, it will self-assign itself a well-known IP address. I think 192.168.10.100. And but because you can find it from the front of the machine, you know, you can always then go and set your laptop. If it's been hard set, if a customer's hard set it to some stupid address for their network, at least you can go and set your laptop to be on the same LAN and recover it, because you can always go and find out what the IP address is by going and looking on the little OLED screen.
And you can't change the IP address from the panel there.
Not from the panel, no.
No, okay. Yeah.
And there's a few other things you can monitor there. You can you know, obviously firmware versions of the 3 boards. Unit ID is a BBC thing, and we'll get to that. Network status, whether we've got TCP control security enabled or not, which basically is TLS for the web browser and passwords for the various functions that the web browser gives you. You know, we can look at the state of the GPI pins on the 9-pin connector on the back, and we can look at the state of the internal power supplies. Now you'll notice on the last line of that screen it says PoE 0.0 volts. If you connect to your network with a PoE port, the thing can stay powered even if you've lost both of the power supplies to the machine. So what that means is that in the event of a complete failure, if your eyePower is being powered by a network switch in another room over PoE 48 volts on the RJ45 connector, then it'll stay alive, and it'll you know, it can still run macros, it can still provide SNMP data, and all those kind of things. So it could alert you that you've lost both power supplies, for example, to that rack, which you know, if you were relying on the incoming power as your power to do monitoring through eyePower, you know, you'd be killed in that respect. But yeah, having PoE on the Ethernet ports is valuable in that respect. So I'm now going to switch to the web interface. So obviously you guys saw this at the show. It's exactly the same, and everywhere you can see one of these big pressable buttons, we can click that, and then the graph below starts to monitor that thing. So that there are two inlets, and we can, and obviously we're not pulling anything on the B supply at the moment because we're running on the A supply, and in fact, if there's no current whatsoever, this is just noise. That this graph auto scales.
Since you can monitor both of them, means it's is it any possibilities you can share? So the first 7 ports is inlet A, and or is it just one or the other always?
It is one or the other,
Yeah.
and there's no room inside for a second changeover board, which is what we'd need if we wanted to split the power between the two. So what are you thinking, that 1 to 7 normally are on A, and
I was just thinking if there was any kind of option to partitionate the outputs, but
not currently. Not currently.
no, I don't see any need for it. I'm just
right. Okay.
just curious.
Yeah, it's the kind of question somebody will ask, isn't it? Yeah.
Yeah.
So when I'm up in this yellow part of the web interface, going between those two, the graph is showing me earth leakage between the two supplies. So any equipment that's connected to the outputs, if that's introducing earth leakage into the system, this is where we can monitor that. But if I go down here to graph total, the graph's now showing me that the load of the equipment that's connected, in total through the machine. And if I go to the individual outlets, I can do the same thing. I've only got one thing connected at the moment, and that's just a little 100-watt power supply, just for demonstration. But as I said to lots of people, that the real power of the fact that we sample 50 times per waveform and with 16 bits of resolution means we can measure the power factor and the crest factor. Which
explain to me, what is crest factor?
Crest factor is how much this cyclic waveform of current consumption differs from the voltage that's supplied.
Right.
So if we had a completely resistive load, like an old-fashioned incandescent light bulb, or just something that was just basically a big resistor that turns electricity into heat, then these two would follow each other exactly. As soon as we start including equipment that is either capacitive or inductive, then the current and the voltage waveforms move out of synchronization with each other, or I should say out of phase with each other, and the current waveform may become non-sinusoidal. So I mean, if you look at this one here, it's kind of vaguely sinusoidal, isn't it? It's kind of repeating.
Yeah, just out of phase.
But I mean, if you know switch mode power supplies, capacitors charge as the voltage approaches the top of the waveform, and then they so switch mode power supplies never have a correct power factor. Now this one's got a pretty good
power factor. Difference is a difference rate, or I don't know how you might measure.
I mean, it's just an integer that if it's 1, then they match perfectly, and as they start to slip away from each other, the crest factor goes up. But having access to those 2 bits of data means that we can see if a power supply is changing, because as power supplies age, the power factor and the crest factor change, and you can see when capacitors are starting to go dry and things like that. And so you can, if you have an external monitoring system, you can start predicting when faults are going to happen. But to be able to do this, you need to have current monitoring transformers. You can't do this with shunt resistors. So I'm going to switch back to the that little camera now. So stop sharing. Okay, so this guy here. So here's a board that I just pulled off the line before it gets assembled. You can see that this is a 214, and you can see each one of these current monitoring transformers takes one outlet from the machine to the back panel, and then so there's one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we've got 3 current monitoring transformers, 2 for the inlets and 1 for the earth leakage. So when this is completed, the earth leakage, the live and the neutral both loop back through one of these transformers, and we can measure the earth leakage, and that's what you see on the web interface. The ability to manage it, measure earth leakage. Now, earth leakage is important because within a facility, the law in England, I don't know whether it's the same across Europe, but the law in England now has pushed us to using RCDs, residual current detectors. For safety's sake, the Americans call them earth leakage breakers. And if you have too much earth leakage on any of your external equipment, that it stops an RCD from being able to work reliably, and it'll cut the supply without there being a need to. So that's why we think it's important to measure earth leakage. And again, you can only really measure earth leakage with a current monitoring transformer. You can't measure it with a shunt resistor, which is the way TSL do all their monitoring inside their unit. So we think, although it's expensive, having current monitoring transformers and 16-bit A to D converters, each one of these is a dual channel A to D. We feel that is the best way to measure current consumption, on a PDU. You also notice we've got high quality mobs, and these are monitored mobs, so they're not just a 2-legged metal oxide varistor. They've got a monitoring leg as well. So again, that gets used, that gets converted in those 2 A to Ds there, and to measure if any of these mobs have failed. So if you've had a big inrush current, a big voltage spike, and any of these mobs have failed, so line and neutral on the A supply, line and neutral on the B supply, then you can see from the web interface why it's failed. Each one of these is the relays for the inlets, for the outlets. These are the relays for the inlets, and then there's an additional board that goes on here, which is a changeover board, which uses a different. You got a changeover board there? Guys, just pass me a changeover board. Thanks, man. So the relays on the changeover board are much higher spec, and that's how we do the 11 millisecond changeover. If we were using the same relays for that, we couldn't get the same rapidity. These are quite expensive, these relays. So that's how we do the AB changeover so quickly. What else can I show you on here? Well, so that's where the 2 microcontrollers go. They're picked microcontrollers. This one controls the display. This one controls the switching of the relays. There's a daughter board that goes behind here, which is the network stack. So that connects to the Ethernet port on the back of the machine, and allows us to does all the networking. It also passes the serial control. Now, the reason we have serial control on these things, which you might think is a bit of a strange addition, the 9-pin D type on the back is an RS485 port, and again, that's down to the BBC. The BBC, to minimise their use of IP addresses, want to be able to stack 4 of these units in a cabinet and have only a single IP address. And so the RS485 port on the back, we supply these looping cables. They can have 1 unit with a network connection, and then the other units that they each get they're each controlled over RS485 on a serial port, which again goes via the same network card that's in the back of the machine.
So this is configured in the software, with
Yes.
kind of master IP address and the other.
Exactly. Let me share. Where's our?
So that means you can also remote control only 1 unit, which is
No.
all by other units.
So let me find. Oh, it's not running. Hang on a second. Let me run that guy. Um, Here's the eyePower utility. Can you see that on your screen?
No.
Sorry, desktop 2. How about now?
Yeah.
Yeah. Okay. Oh, I'm sharing screen. What screen am I sharing?
I see the diagram now. A new window comes in.
Okay. Okay. So this is the the Windows utility, and
Yeah.
so I know we're on this IP address on our network. Connect. This is what so the whole serial business is what all these things are up here. Um, so if we're talking to so we have to configure it initially over the network. You know, as they go into say you've got 4 units in a cabinet, we'd have to go down and configure each one over IP. But then if we come away from FA, we can give it an address which is an RS485 address.
Mm-hmm.
If we had the first unit as unit 1, which had the Ethernet connected to it, then we'd go through and we'd set the next units to 2, 3, and 4. And so long as there was a serial cable connected, they'd then appear in the interface here, and we get an additional tab here on the web interface. We get an additional tab that basically
Where you can
allows
select
us.
the unit.
We can select 2, 3, and 4. You know, 1, 2, 3, and 4, where 2, 3, and 4 are connected over RS485. Again,
And you
that's
have
a BBC.
full access to all the information, same as the IP connected one.
Yeah, absolutely. So the way it works is is that the network card, if it sees that ident number in the preamble, it just passes it straight through to on its serial loop, and it doesn't even know. It's relying on somebody on the serial loop listening for that identifying packet number in the preamble. So if something's configured as an IP machine, and it sees that packet arrive, not with an FA0 marker on it, but it says FA02. It says, "Oh, this is not for me," and it just passes that packet out through the serial ports. And you rely on another machine being configured as a number 2 to see that packet and take it and do with it what it should do. So it's a simple system, and again, the BBC are the only people who buy that. Nobody else has ever bought that. But since the BBC own more than 1,000 units, it was a worthwhile thing to do for the BBC. So that's the whole network control, serial control. It just means you can have up to 4 units on a single IP address. Here's the configuration utility. If you connect to a machine that's got a real working IP address and read the network ID settings, you know, we get all the stuff you'd expect. So this one is set to obtain an IP address automatically, but if it doesn't get an IP address, here are the network details it will fall back to. If we uncheck this, we can just hard set the IP address. You know, we hard set all these details anyway. You know, if it's a network that doesn't rely on DHCP. NetBIOS name is we support NetBIOS for discovery. So if you've got you know, if you ping that NetBIOS name, then you'll get the IP address back. I don't know if that's of any use. These two settings here are just what appears in the web interface and also on the little OLED screen on the front. You know, we can. This is if a machine is a 42 machine, we can disable TCP control. And if we want to use HTTPS to control a machine, we can do pre-shared chassis, which is a lightweight public-private key crypto system, which again is a BBC requirement. But nobody else has ever asked for that. the BBC wanted HTTPS security on the web interface. We've got another layer of security where we can disable access without a password. So in here we can stop people being able to go into the admin tab and run macros or reset the network board, that kind of thing. Or we can stop them from running macros from the web interface. And so, obviously you can imagine that some people, it's appropriate for them to be able to have view privileges where they can see the web interface, but not control or admin privileges. So that's, there's nothing, nothing special there at all. It's all stuff, you'd expect. Channel names, again, is just what appears on the unit status page on the web interface, and also on the little OLED screen on the front. Kind of what you do, but these are sort of things you put on there for trade show and never change them. Macro triggers is basically what macros are present in the unit at the moment. We can the unit ships with just two macros, one of which is a sequence startup, one of which is a sequence power down. But we've got this macro editing tool, which is very basic, but basically does all the things you might want it to do. So when the machine powers up, this is just a couple of hundred bytes that are spare on the microcontroller, and we've got this little system where we've got some commands, and we can read things and do things based on the decisions. And so when the machine powers up, it starts executing from memory address 10. So the very first thing it does is it enables flashing of LEDs and beep should they be needed. It disables GPI reading on the back in case a GPI event occurs while the machine's setting itself up. And then it sets so the little power button on the front is not a power button at all. It's just an interrupt. It's just a GPI, but it's a special case GPI. So the first thing we do is we set an interrupt to run at address 1A if that power switch gets toggled on, and we set another interrupt to run at address 2A if that power switch gets toggled off. Then we re-enable the GPIs, and that's it. We stop. But we, of course, have set up these two interrupts. And the first interrupt says what happens when the machine gets turned on. And so this is the little script that runs when it sees that event happen. And very straightforward. The same thing for when we trigger the interrupt that's now been pointed to memory address 2A. What happens then? Well, we just turn off, waiting half a second between each one. And we can write some little macros to run in the event of things happening. So the one I normally do for people is, I say, okay, so you're putting one of these in the data center. Which port on this PDU are you going to hang your network switch on? Because we never want to leave the network switch turned off all the time. I mean, you may want to power cycle it, if you suspect that it's crashed or whatever, but you never want to leave it turned off. And so I normally set a macro that says if outlet 14, for example, has been turned off, wait for 2 seconds and then turn it back on again. So you can never leave outlet 14 or whichever one you choose powered off all the time. And again, it's just a very modest selection of commands that are available in this little scripting system, for enabling GPIs, reading the state of GPIs. We have 2 counters we can increment and read and things like that. But it's as basic a scripting system as you could have, but it still allows you to have some smart features, on the machine that aren't controlled externally.
But the one we see now is one of the factory default macros?
Yes, yeah, that's right, yeah. So the one here that starts at address 2A, let's go back up to the start of that one. So we set an interrupt when the machine powered on to say, if you see the power switch turn off, then run the script that's at memory address 2A, and that's what it'll do. It'll start running that script until it hits a stop command, and then it'll stop. I can't remember if we ship. Oh yeah, so we ship a few demo scripts with the unit, um, uh, so people can get familiar with how the system works. Um, so
Okay.
but I'm not going to upload that into the machine at the moment.
No.
Um, so we should then talk about OneWire, because OneWire is the sensor system that we support. OneWire is a very common. I think it's a I squared C variant, but it's a very common sensor um, 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 protocol for very simple monitoring of temperature and humidity. So if I stop sharing this, and we're still on that camera there, if I go and look on the back, you can see there's two RJ45s on the back. The one with the skinny cable is connected to the network. The one with the this white cable isn't connected to anything at the moment. But if I take one of these one wire sensor units, this one is a humidity and temperature sensor, and I connect that. And then if we go back to the web interface, so share that guy there, then you will see that we've populated a couple of extra positions at the bottom of the one wire window here. So we've got an internal temperature, which of course is a bit warmer than the external temperature. So we've got external temperature and external humidity, which is being sensed by that little box. And then we have these other sensors, which it just looks like a very long string, but it's
How many
it's
and
meant.
how can you connect more sensors?
Okay, so give me let's.
It's,
So every one of these
this,
one wire units has a loop through on it, and it's a multi-drop
this,
protocol. So even if it doesn't come with a loop through connector, you could make like a Y cord, a splitter or whatever, and you can connect them in serial or parallel. It's just a very basic protocol that allows multiple sensors. So if I plug in this extra one here, and you can see this is like a string. Um, this one has got lots of temperature sensors in it, so they're just little lumps in the cable.
yeah.
And if I go, that's looped through on that guy there. So if I go back to our web interface, you can see we've now got a bunch of sensors here.
Mm.
And some you can use these to if you're worried about thermal gradients inside a cabinet, you can put this string down the back of the cabinet and measure those thermal gradients. But I want to so let's go back to our
Could you then connect it with a GPO and start a fan or a temperature control or do anything, any action?
hang on a second. Let me go back to the Windows utility. So which screen are you currently seeing?
I see a lot of screens.
See your calendar and your
Okay,
chat.
right. Okay. let's get rid of those, shall we? So if I read the one wire data, you can see that it populates it's like a MAC address for all those sensors, and I can hard commit those sensors so that it doesn't have to scan for them next time. I don't know that there's much point in that, but this is where we manage all that side of things. Now, if we go back to the macro trigger, I don't know if you can do things based off of heat.
No,
I'm gonna have to talk to Simon about that. I don't know. Sorry.
it's just a question.
Yeah,
Just
but all this stuff gets exposed over the SNMP interface. So I don't. All I have is a very basic SNMP MIB browser here. But this. I just loaded the MIB for an eyePower, gave it the IP address, and it's starting to collect data from the eyePower. Now,
And from
as I
there,
say,
you
I
can
don't.
control anything, I guess.
Yeah, but you have to know SNMP, which I don't. But all the monitoring software that people use, things like Data Miner
Yeah.
or what's the very one that's very popular in IT? What is it
Yes.
called?
VSM, maybe.
Uh, uh, I don't know about VSM, but anything that can take an SNMP MIB uh,
Yeah.
can then start harvesting data. We've already got drivers written for. Oh, damn! Yeah, hang on, I'm just going to grab a one of the leaflets. So Grafana, that's what I was thinking about. I see that in lots of places. People use Grafana.
Yeah.
So data miner, Grafana, AMX, BNCS, broadcast control system, control for DeMots. But basically anything that can ingest SNMP data can see all the uh, 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 data that we're harvesting, which is all this stuff and all this stuff and all this stuff. So it's quite a complete solution in that respect. The BBC wrote their own SNMP monitoring system called Custardware, and I'm talking to the developer now about doing a branded version for us because he's not tied to the BBC. He could do that for us. So again, we might be able to do like an interesting cheap bit of software that people could use to monitor lots of these things. But most people seem to be happy just being able to look in on the web interface and change things using the web interface. But it's all exported via SNMP.
Yeah. Is it any other way you can export this data? I mean, Excel or is it anything?
I, you could probably write an Excel script to
Yeah.
scrape an SNMP load,
I mean,
but I don't
for
I
logging
don't know.
reasons.
For logging reasons, I think you'd be using, if you had an existing house logging system, so you're logging your switches and things like that, then I don't know, but I'm told that it's not hard to write an SNMP driver in most things because you just have to scrape the data and then take uh, take the names of all the cells in the SNMP file, and so apparently people well, Simon tells me it wasn't hard. It took them less than a day to write a plugin for Grafana to do it, for example.
Understood. Great. Okay.
Okay, I mean, is there anything else I can tell you guys? Is it?
No, to me it looks perfectly clear. I would like to sit a few hours just to play with it, but
Yeah.
how about you, Rolf? Any questions? And
No, I think
you will be the guy presenting this next week.
yeah. Please make the recording available, Phil.
Oh yes, of course. Yeah.
Yeah, no, but it is relatively clear. The Windows software,
Yes.
is that downloadable or can you
Yep.
provide it?
No.
It is on.
That's the Windows utility, the SNMP MIBs, and all the marketing material and the price, the product, variation list is all on the website.
I found it. So
Under the support or software, yeah.
I
Okay,
think I
yeah. Got it.
So Phil, is there any other places than broadcast centers you would recommend us to go to check the interest for this product?
Well, I mean, I can only tell you who the big users in the UK are, and the four biggest are BBC, Disney, Amazon, and Netflix. Now, obviously, the BBC is a big broadcasting place, and most of theirs are in Cardiff. However, they're currently threatening to give us an order for 200 for their new recording studios, which are going to replace Maida Vale. ITN, who are a big news provider in the UK, They just asked us to quote for 40 units because they like the demo. So I think it's a real mix of places that have got big rack rooms with lots of cabinets, and they want to keep an eye on power consumption, all those things, and smaller places. So, for example, Amazon buy them, Netflix buy them just one or two at a time, and they use them for just the single racks that are in their viewing rooms around Europe. So it means that London can remote in and check things and reboot things and stuff like that if they need to. So
what about OB vans and stuff like that? Would that be a place to try to push this?
I don't know. I mean, I imagine an OB van doesn't need much remote monitoring because if it's working, it's got engineers on site, hasn't it?
Yeah.
But maybe people need alerts to say if something's overcurrents or something. I don't know.
Yeah.
Don't know.
How
And
about
Telenor,
server parks, telco centers, and these other?
yeah. I mean, my view is that the big push for us over the next year is going to be data centers. There's a lot of new data centers being built in London, and that's, I think, where there is value for people, where they can really with good granularity see how much power they're using and all those kind of things. The big complaint we get with people who are talking about data center use is they say, why isn't it available in a vertical format? In that kind of format, because we want we want to be able to put it down the back of the rack. We don't want to have to use one. We don't have to waste a one rack unit at the top of the rack. Our problem is that if we're doing it with current monitoring transformers, we can't reformat this so that it works physically as a 0U vertical PDU. It's always going to be a one rack unit PDU, and that's just a fact of life, unfortunately.
But you could probably extend the cables from the outputs to a vertical.
Maybe. I have talked to Simon about maybe building a vertical,
kind of a squid
just a
cable.
breakout. Yeah. So maybe. But again, the problem there is that when people buy those vertical units, they expect there to be, like 12 10 amp C13 outlets and some C19 outlets as well. And I don't think we'll ever get that variety. Maybe. It's not, never say never, but we haven't, concluded anything yet.
Yeah.
But you will always get that question. Why don't you do that?
Yeah.
Always.
You can make whatever you want, but there will always be a different demand.
Yes. There's always people, got their own special. And how many will you buy? We'll buy two.
Yeah.
So we'll invest £50,000 in developing it, and you'll buy two.
Yeah. Actually, we had one earlier this year. He said, "How many One Mini 03 and 04 do you have in stock? I'll buy them all." And he bought two.
Yeah.
Oh, yeah.
That's good. Well, thank you so much, Phil. This was really helpful.
There's just one thing I want to ask you. Have you got an old, even just the metalwork? Because the metalwork guy, he was worried that the RAL number and the Pantone number didn't produce exactly the same shade of green. So he wondered if.
Yeah, I checked it with a paint shop just close to here, and I have a friend working there. He said that the RAL code is the closest you can get.
Right.
It's a little bit darker and it's a little bit more yellow than our original color, but it's impossible to compare these because there's some other parameters in the RAL code as well, like the texture of the paint and so on. So I think it's the closest you can get.
Okay, and you'd be happy with that. You don't want to send me a like a chassis of an old Bond Mini that I can show the guy. And
we have so many variations in our color because of different techniques. So I don't think it will be much difference.
Okay, great.
So I think it looks good.
Fantastic. Okay.
But please check with the logo thing.
Yes, yeah, no, I'll make that today's job to persuade the guy.
And
I
I
mean,
will,
in a year's time, it won't matter, but I think now we have to tread a tiny bit carefully.
yeah.
Yeah.
And I will communicate further with Elaine. She's making the price list for the new products. And yeah, it's more work than expected. We need to make user manuals, the marketing things. There's a lot of things introducing a new product.
Yeah, no, for sure. I'm
A lot
looking
of work.
forward to getting a green version of that fiber scope. That'll be great.
Yeah, we're waiting for it. I'm
Yeah.
not sure what is the latest status now, but it's in production. That's all I know. So you got a nice lead yesterday from CT.
Yes, yeah, and I've got I think 3 leads now for the fiber for the barn doctor. Is
Yeah,
that what you're calling it, barn doctor?
that's what's proposed. I'm
Yeah.
not 100% fan of the name, but okay.
No, it's great. It's fine.
It doesn't repair anything, does it?
My doctor never repaired anything.
Ah, no.
Just told me what's wrong with me.
Yeah.
And I've just received this morning that barn one, which goes to the BBC next week.
Okay.
So the BBC going good. They've had
Yeah, it's
lots of barn
frequent
minis so
ordering.
far
Yeah.
this year, and so yeah, getting friendly with those guys.
That's cool.
Absolutely. So I'm happy to see that. And we're busy on the house with this Brazil chaos. We have they have made 2 phases of the project. So we got the first one confirmed and even paid. That's just a smaller part. And then we are waiting for the second phase, which is the complete total order. And they still haven't decided who's going to pay it, how the technology is going to operate, what colors in the barn colors. Nothing is decided. And now it's almost October, and they
Right, and they
expect to
want
deliver it in Brazil October 10th.
heavens.
Yeah.
I mean, that's like 2 weeks away, isn't it?
Yeah, and we need to produce the circuit boards and everything. So
Yeah.
probably I have to go to China with an empty suitcase and just pick up something.
Oh, wait! You just bring the parts back.
We have no time to wait for a DHL airplane or. And there's a national day in China on October 1st, and that lasts for a week.
Yeah,
And
no,
the
So
capital is to shut down.
I went to see the company that assembles our PCBs a couple of days ago, and they said the same thing that they're expecting a delay because they get
Mm.
all the PCBs, the boards manufactured in China, but they populate them here in the UK.
Yeah, yeah. So yeah, they keep us busy over there. But thank you, Phil.
Okay.
Is it possible to take another session with the Germans then on October 6th?
Yeah, for sure. If you think this format has worked, then
Right.
absolutely.
Perfect,
Yeah,
perfect.
yeah.
yeah,
And they
So
will
we need
probably
to know.
have different questions than we had, and
for sure.
then they will be ready and prepared for the exhibition starting 12th or 13th.
13th, yes.
Yeah.
Mm.
And
So
also,
are either of you guys going to that show?
I'm going.
Right.
So I will actually be driving down there to so that I can bring the necessary equipment.
Okay. So is that Hamburg or where is it?
Hamburger, yes.
Hamburg.
So it's
Wunderbar.
yeah. So
so many exhibitions.
it's the ferry from Larvik to Denmark, and then it's a 6 hours drive, something like
Well,
that.
you know the way.
Make
Been
sure you
there.
stop for a coffee.
Yeah, I'll probably have a drive through somewhere and get a coffee.
Okay, I'll see you guys soon. Yeah.
Yeah.
Yes,
Okay.
and
Thank you very
that
much.
means I can invite you and the Germans for a session. Is there any
Yeah.
specific time on that
Do you
day?
want? No. I think let's look at my calendar
Or
once you guys have
if
seen
you want
already.
to use the Zoom, maybe I send you a list of
Yeah.
names.
Yeah. So you said the 6th, yeah? yeah, I'll keep that day free. And if you tell me morning or afternoon, then
I don't know. I will need to communicate with them as well to find a date where, or the time, which is perfect for everybody.
Yeah.
okay,
Yes.
great. I'll talk to you guys soon.
Okay.
Yes.
Thank you very much, Phil.
Thank you.
See you soon.